Welcome to this video on electrons and atoms. So we want to know the general places where we find electrons and how electrons fill in an atom. And so this first slide shows the Bohr model, and the Bohr model is actually not quite correct, and we're going to look at the correct one today, but in a long line of models to try to discover what an atom would look like, this actually gives us some really good and important information. And so when we look at this, we see these rings, and these rings actually could represent where the electrons are. So we have the nucleus with the protons and neutrons, and then these rings actually can be representative of energy levels. And so even though it's not entirely correct, we can use that as energy levels. And so the closest one would be the first energy level, and then the next one would be the second energy level, and so on and so forth. And when we look at this and we compare it to the current model, which is the quantum model, we see it's a little bit different. And so again, there's the protons that are positive and the neutrons in the nucleus, and we still see those rings. And so a lot of times we think of those rings as being something we would call orbits, right? So it says right here electron orbits, and that's actually not correct. That's not where electrons are found, so not correct. We actually find electrons in regions of probability. And so in the quantum model down here, we see these things called orbitals, okay? And so say that very first, that we would have these orbitals, okay? And an orbital is not an orbit, okay? It's a region of probability. Where we are most likely to see an electron. Now we have different types of orbitals, and so with the quantum model there's a lot of different aspects of how these electrons fill in, which we will be working on over the next couple of videos. So we want to know about our quantum model and energy levels. So I said that the energy levels on the Bohr model, they actually match up with the quantum model. And so we have these things called principal quantum numbers, and they are also the energy levels. Okay? And so when we are talking about those ring structures in the Bohr model, which is what most people are most familiar with, that's what we see. And we can have energy levels 1 through 7. And with those energy levels of 1 through 7, those are the different levels. And so if we look at the periodic table, there's actually 7 rows, and they coordinate with those 7 energy levels. And electrons are located at distinct energy levels. They're not located in between levels, and so we'll see them at those certain levels. And the amount of energy that we would need to have for that is called a quantum. Okay, or a quanta of energy, and it's in a distinct amount of energy. So you can see on this slide where we have these regions of probability, these orbitals, and so there's 2 that I want you to kind of know about. And the first one, there's more than that, but it gets a little more complicated. Actually, maybe I'll use the red. So we see that this spherical shape is where we are most likely to find the electrons. And so the closer you're in, actually it's more concentrated, and we'd be more likely to find them there. And so an s orbital is actually spherical in its shape. Okay, and then we have this p orbital. So the p orbitals, call them figure 8 or maybe dumbbell. And you'll notice at the very center, so these ones are figure 8, p orbital, so figure 8, or dumbbell, either way works fine for those. You'll notice at the very center, these are the nucleus, and remember the nuclei, there are no electrons in the nucleus. And so we're most likely to find these electrons in those regions, and and there's a whole structure for how that can happen. So the next slide that you're going to see actually shows all of these different orbitals. Okay, and so we see at the top we have the s orbital that's spherical. So there's our s orbital again. Okay. And then we see the p orbitals, and the p orbitals, there's actually 3 p orbitals. So we have, they designate them, this one's p minus 1, po, and p1. We can also see them as p, x, y, and z. So that's the other way. So this one's along the x-axis, so we might call it px. This one's along the y-axis, so we would call it py, and then this one's along the pz axes, and so that's also, but they're all that shape, and there's 3 different ones. And then as you go down, the d's and the f's, they get quite a bit more complicated. And so we don't really need to know the shape of those as much, but we do still see them. So I know this is kind of theoretical and sometimes it gets a little confusing, but I want to talk about those sublevels of the quantum model. So instead of just having different rings that move out further, each one of those energy levels that we were talking about have a specific amounts of sublevels. And so the S ones that we said were spherical, there's only 1 orbital for that. And the maximum electrons that can fit into any orbital is 2. And so I'm going to write that up above here. Oops. My hand hit that wrong. Only 2 electrons can be in a given orbital. Okay, and so with the first one here, we see that S only has 1 orbital, so they can only have a maximum of 2 electrons in that entire sublevel. Now for the P's have 3, so we talked about the PX, the PY, and the PZ, and in each one of those they can have 2 of them, so 3 times 2 is going to give us a total of 6 electrons in that sublevel, and so on and so forth. So in the D they can have 5 orbitals, 2 electrons in each, so a total of 10 electrons in that sublevel. And for the Fs, they can have 7 and a total of 14. And we're going to see in another video how this kind of relates to the periodic table to help us. This is just kind of a brief overview of this. And so if we want to see an even larger, probably much more confusing, not that I'm trying to confuse you, way of looking at the quantum model, the next slide is going to be a big overview of the quantum. And so in this one you see the principal energy levels or the principal quantum numbers. So we see our 1 through 7. We see the number of sublevels that they have, and so in the first one we only see a 1, and that would just be the 1s. Okay, and in the second level that we actually have 2 sublevels. We have the 2s and the 2p, and so on and so forth down here. And then it tells you the total maximum number of electrons that you could see in that level. And so a lot of times if you've looked at the Bohr model, you'll see 2 and then you'll see 8, and so on and so forth. And actually this is representing those energy levels if it's the Bohr model, but in the quantum model we need to know a little more detail, and we're going to work further to understand how we can use this information in the next video. I hope that was helpful.